Hello students, let us continue with chapter 8 quadrilaterals, exercise 8.2 on pages 150 to 151, question number 5. It's been given that quadrilateral ABCD is a parallelogram wherein E and F are the midpoints of sides AB and CD respectively. That means AE is equal to EB and CF is equal to FD. We have DB as the diagonal and we have joined these line segments A to F and C to E. That means one vertex of your quadrilateral, that is vertex C, is connected to the midpoint E on side AB. Similarly, A is connected to the midpoint of side DC. So, we have AF. Now, we need to prove that AF and EC trisect BD. So, when you say bisect, what does it mean? Bi means two and sect means section. That means you are dividing something into two equal sections. Similarly, trisection would mean dividing something into three equal parts. So, 3 and equal are very important here. So, when you trisect BD, that means BD is getting divided into three equal parts. So, what do we really need to prove? That DP is equal to PQ is equal to QB. Once you prove this, you can easily say that AF and EC are bisecting B, because if you see, AF is cutting DB at point P and EC is cutting BD at point Q. So, how would we go about this proof? First of all, if you notice, you have your parallelogram ABCD. Obviously, you can say that CD is parallel to BA, correct? So, what further can, why? Because they are the opposite sides of my parallelogram. Therefore, half of CD is always going to be half of BA. Since we have E and F as the midpoint of AB and F, AB and CD, what can you say? That AE is equal to CF. Also, DC is parallel to AB again because they are the opposite sides of my parallelogram. Therefore, FC is going to be parallel to AE. Why? Because F lies between CD and E lies between AB. Therefore, in this quadrilateral AECF, we just showed that AE is not just equal but also parallel to CF. Therefore, we can conclude that AECF is a parallelogram. Let us write this much down, then I will tell you how to proceed with the proof. So, I will say in parallelogram ABCD, AB is equal to DC, opposite sides of parallelogram. Therefore, half of AB is equal to half of DC. Since half of AB I will take here as AE. Why I am taking AE and CF out here? Because I need to show that this quadrilateral out here is a parallelogram. So, AE is equal to FC. Since E and F are midpoints of AB and CD respectively, correct? Also, I have, so let us mark this as statement number 1. Also, I have AE is parallel to FC or CF. Let us say FC itself, because we have written FC over here. Why? Because AB is parallel to CD and what do we have? F lies between D and C and E lies between A and B. So, E lies between A and B and F lies between D and C. Let us mark this as 2. So, what do you get from 1 and 2? That my quadrilateral AECF is a parallelogram. Quadrilateral AECF is a parallelogram. I will say from 1 and 2. Let us mark this as 3. Now, we have proved that this line segment, this quadrilateral out here is a parallelogram. So, now if you take into consideration your triangle APB. It's been given that E is the midpoint of AB, and obviously these two lines are parallel because they are the opposite sides of a parallelogram. Therefore, EQ is parallel to AP, correct? Because Q lies between E and C and P lies between, Q lies between E and C and P lies between A and F. Therefore, what can I say? That Q is the midpoint of BP, which implies that BQ is equal to QP. And why did I say that Q is the midpoint of BP? Through the converse of midpoint theorem. So let's write this down. In triangle ABP, I have E is the midpoint of AB. This is given. Right? And also what do I have? That EQ is parallel to AP. So why EQ is parallel to AP? Because we have quadrilateral AECF is a parallelogram, and what else? That Q lies between E and C, and P lies between A and F. Correct? Therefore, what can I say? That Q is the midpoint of BP. Let's mark this as statement number 4. And why did we get this? Through converse of midpoint theorem. So let's not mark this as 4 because we need to prove that DP is equal to PQ, which is equal to QB. So we'll say BQ is equal to QP for now because Q is the midpoint. So BQ is equal to QP, and let's mark this as 4 because we might need this for reference. Now similarly, if you take into consideration your triangle DQC, what do you have? F as the midpoint, and see these lines out here. FA and CE are parallel to each other. Why? Because we proved that quadrilateral AECF is a parallelogram. Therefore, obviously FP is going to be parallel to CQ. Why? Because P lies on FA and Q lies between C and E, and these two lines are parallel. So FP is parallel to CQ. So for this triangle, F is the midpoint and these two lines are parallel. Therefore, through converse of midpoint theorem, I have P as the midpoint of DQ, which implies that DP is equal to PQ. Right? Let's write this down, and then we'll take what conclusion we just drew over here with point 4 and prove that my diagonal BD is getting bisected by the line segments AF and FC. So I'll say now in triangle, so which is my triangle DQC. DQC, I have F is the midpoint of DC. This is given. And also FP is parallel to QC. Why? Because quadrilateral AECF is a parallelogram and P lies between F and A, and what else? Q lies between E and C. Correct? Therefore, what can I say? Therefore, P is the midpoint of my line segment DQ through converse of midpoint theorem. Now P is the midpoint of DQ. So what does it imply? That DP is equal to PQ, correct? Therefore, DP is equal to PQ. Let's mark this as 5. So what do you get from 4 and 5? See, notice over here we have PQ. So instead of writing PQ, I'll write QP because we have QP over here. QP and PQ are the same thing. So, or rather I'll write it as PQ over here itself because we need PQ there. So PQ here and PQ here. So from 4 and 5, what can I say? That BQ is equal to PQ and this is equal to DP, correct? Therefore, DP is equal to PQ, which is equal to BQ from 4 and 5. But what do we need to prove? DP is equal to PQ, which is equal to QB. So let's just write BQ as QB in your last statement. DP is equal to PQ, which is equal to QB. See, QB and BQ are the same line segments, right? Therefore, I'll say AC, AF and EC trisect diagonal BD. So this was about question number 5 of exercise 8.2. Thank you for watching the video. We'll continue with the remaining questions in the next videos. Thank you.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.